So good morning, everyone, and welcome to today's session, all about Highcharts in Amazon QuickSight. My name is Jackson Dowden, and I'm a solutions architect with QuickSight, and I'm super excited to be here with you all today. This is going to be sort of a part 3 following our previous sessions led by myself and my colleagues. The first session was an introduction to the Highcharts charting library and included the basics of linking your data, exploring the chart code editor, and looking at some of the possible customization options that are available. In the second session, we went through creating enhanced versions of native QuickSight visuals, as well as using bespoke visual types that are not natively available, and how you can leverage the native themes, filters, and sorting of QuickSight with your Highcharts visuals. In today's session, we will continue looking at some advanced Highcharts use cases, including interactivity with parameters and advanced data and color formatting. So in case you missed the previous 2 sessions, or if you're unfamiliar with the Highcharts integration with QuickSight, I highly recommend that you check out the recordings posted on the Amazon QuickSight YouTube channel, as those help form a foundation for our discussion today. But with that being said, let's jump right into it, and here's our agenda for today. So we'll spend most of our time in today's session in the QuickSight console building visuals together. But before we get to the demo portion, we're going to start with just a quick review of what Highcharts is and the key features. And then, as Madison said, at the end of our session, we'll also be sharing some relevant resources and have some time for Q&A. So just as an introduction, Highcharts is a popular charting library that was integrated into Amazon QuickSight at the end of 2024. With Highcharts visuals, you can now create custom visualizations using the Highcharts core library, available at no additional cost. This library allows for advanced customization options and provides more bespoke chart type options like sunburst charts, network graphs, 3D charts, and more. This library is available as a visual type within QuickSight, but unlike the drag and drop nature of our native charts, with Highcharts, there is a chart code editor where you configure the visuals using Highcharts JSON schema. While this does require more configuration, the code editor comes with contextual assistance features, including autocomplete and real-time code validation to help improve this visual creation process. And as I mentioned, it also provides access to more advanced customization options as a result. So here on the screen are some sample Highcharts visuals that are provided in our Demo Central website, where we also provide the chart code so you can see exactly how each of these visuals were made. We'll be linking to that in the resources section later. But that was just a quick recap of what Highcharts is. So let's move over to the demo, where I'm going to switch to my browser window. So here I have QuickSight open to a new analysis. And for today's session, we're going to be using a sample SaaS sales dataset. And in the interest of time, we're going to start with a basic chart already created. So here you can see we have a simple pie chart showing the sum of our sales for each of the 6 industries in our dataset. Now, as I open up the properties of this visual and also the chart code editor, we can see that this is a Highcharts visual and not a native pie chart. On the left, you can see that I've provided the industry and the sales fields to the visual field wells. And in the chart code editor on the right, we can see how the visual was configured. So in this first section for plot options, I've included some properties controlling first this inner size. This controls the size of the inner donut hole. This section on the border width and the border color is what adds these thin white dividers between the slices of our pie chart. Then we've also turned on our data labels. So around the circle, we're seeing these data labels here for our industry and their sales. Under the next section for series, this is where we have set this as a pie chart. So we've said type of pie. And this is where we've actually mapped our data from our 2 data fields that we provided, industry and sales, to the required properties of name and Y. So hopefully this data linking is already familiar, as we won't be going into too much detail today. This has been covered in previous sessions. But just as a quick refresher, we can quickly walk through the logic here. So to start, you can think of this map operation as sort of a for each operator. This get column will return an array of values based on the provided column index starting at 0. So if these are our columns, these are fields that were provided to the visual, this would be the first column as column index 0 and then column index 1. And as we'll see later, when we start adding more columns, it goes 0, 1, 2, on and on. So when we call get column of 0, this would return an array of the 6 industries. So this would just return this column. And when we say get column 1, it would return just the second column, which is our sales column. And when we call them together, so get column of 0, 1, this will return an array of arrays where each element is a pair of values, so the pair of its industry value and its sales value. So get column 0, 1 is saying, let's pair up our industry and sales. Finally, the statement below for the get item 0. This is an operation that basically says get a certain item from the current object by an index position. Again, where 0 is the first item and 1 is the second item. So putting it all together, this whole map operator is basically saying for each pair of industry and sales values, the first value in the pair is going to be the name of the slice, which is the industry, and the second value in the pair is going to be the sales value, which is controlling the size of the slice. And that's the difference between the name and the Y. So name is the name of the slice and Y is the size of the slice. And we're basically just mapping that back to the columns that we provided. So that's where we're doing the data mapping. And then just below in that last section, we're controlling the tooltip. And you might notice that in both in the data labels above and in the tooltip below, we can reference these properties that we defined as part of the formatting. So if we look at the data label format, we see that we're taking the individual point's name. So point.name is this name property, which we just mentioned was the industry. Then we provide a colon, a space, and then we take the values, the Y value of the point, so the sales value. And we had a prefix for a $sign. And then this is just formatting for that number. So this like colon, comma, 0.0f, that basically just says we're going to format this as a number with 0 decimal points. So like 0 digits after the decimal point. And this is why, as we look at these data labels, this is why for each slice, we see the point's name, so the industry, so like energy, colon, space, $sign, and then the sales value for that industry. And that's just an example there. So at this point, we've not done anything too crazy, right? This is a basic pie chart with some minimal configurations around the data labels and the formatting. But really, the main thing that we've done is simply linked to our data. So link these two columns back to controlling how this chart is generated. So with this as our starting place, the first advanced feature that I want to talk about today is parameters. So for many of you who have built dashboards in QuickSight before, you likely have used parameters as they are a really powerful feature that allows for a variety of advanced use cases. So parameters are named variables in QuickSight that store values that we can reference in many places, including in calculated fields, in filters, in text boxes, titles and descriptions, actions, and more. So basically, parameters are often used to introduce advanced interactivity into your dashboards. For our example today, let's assume that we want to give our dashboard users the ability to select which metric is being charted in our graph. So right now we're charting sales, but we want to give the option for our users to select between sales, quantity, and profit margin when we construct this pie chart. So to start, let's simply create a parameter for this metric selection. So parameters are up at this button up here, and we will add a parameter, and we can name this whatever we want, like something like metric. We will leave this as a data type of string, and we'll set a default value of sales. Then when we create this parameter, we will also want to create a control so that our end users can actually set the value of the parameter. So we'll give this control a name, and we'll pass in the drop-down values that we want them to choose from. So we want them to be able to choose between sales, quantity, and profit margin. We can also hide the select all so that they can only select one at a time. So basically now we have this control at the top where we can choose between these three values, sales, quantity, and profit margin. But of course, you'll notice that at this point, as we start selecting these different values, nothing's changing in our graph because we haven't connected it to our parameter. So at this point, we're simply storing the value of the user selection from this control in this parameter called metric. But the next step is for our Highcharts visual to be able to actually react to the selection. Now, currently, we're not able to directly reference the value of parameters from within our Highcharts code. But as a workaround, we can first create a calculated field that does. So we will add a calculated field, and we can call this the selected metric. And we can simply have it equal to the value of our metric parameter. So now we have a calculated field. It's just going to be the value of the parameter from the selection from the control. We can save this. Now, instead of referencing the parameter directly, we can provide this calculated field to our Highcharts visual to reference it indirectly. So we have our existing columns here. I'm just going to add the selected metric so we have that additional column. Now notice how when we add this new field, our visual breaks because our mapping logic was tied to the order of the columns, which we've just changed. So if we come back into the properties here, remember that we said get columns 0 and 1, where the second value is going to be sales. But now industry is column 0, selected metric is column 1 instead of sales. So within our chart code, we can simply add the column and update the index references. So we'll say we want all 3 columns now, so index 0, column 0, 1, and 2. And then now within this set of values, industry is still the first value, but the Y value for sales, instead of being at index 1, is now at index 2. So we can update this value to 2 and apply the code. You'll see we've just returned the visual. Now, before we continue editing our Highcharts, I want to take a quick step back and first understand what we are actually providing to this visual in terms of our data. So if I add a table really quick, and if I add the same fields to this table, so we've got industry and selected metric in the group by and sales as the value. So I can add those same fields, industry, selected metric, and sales. Okay, so this is what the data is that the Highcharts visual actually has to work with. So here we see the pairs of our industry and sales values. But then for the selected metric column, we have a duplicate value now for each row based on the parameter value. So even though the parameter itself is a single value, it is duplicated across every row from our calculated field. So if we go back into our Highcharts code editor, we can add a title to the very bottom here, just as a simple way to visualize the output and basically to print. So I'll just add a title really quick. And we can take the get column call. We can copy paste that here. And we can basically use this as a print. So I'm adding our get column 1, the result of this, as a title, so that when I apply this code, we can see it printed across the top. So this is basically just an easy way to visualize what we're seeing, like what this get column is actually doing. So again, this is now getting the entire column at index 1, which is selected metric, which again, as we just saw in that table, is a bunch of duplicate values. So even though the metric, the parameter itself is a single value, we're seeing this duplicated. If we want to reference the single value of the parameter, however, instead of an array, we can collapse it by using the unique operator. So if I add in unique here, and then apply code, we'll see now we've collapsed this into a single value. So what we're doing here is we're using the JSON operator for unique. It basically takes an array of values and it just pulls out the unique value. So because we know that every row is a duplicate, they're all the same value, when we take the unique operator, we're going to get a single value as a response. So we've essentially collapsed the value of this calculated field back into the single value of the parameter. This is going to be important in the next step. So given that context, we can then use the logic operators in the Highcharts JSON to react to the parameter value. So since we want to add additional options for profit margin and quantity, we can first add them to the field wells. So we'll add in profit margin and we'll add in quantity. And then we can also choose the aggregation of these different fields separately. So it might make sense to do the sum of our sales and the sum of our quantity, but our profit margin is actually going to be a percentage. So for this one, we can change the aggregation to something like average. Next, we will bring these columns in with our data mapping. So we're going to extend the get column call to include the additional 2 columns. So now we want these additional columns, which are index 3 and 4. Now, instead of simply giving the sales value at index 2 as the slice size for the Y value, we can use the case operator to introduce conditional logic. So I'll just move this down. And the format for the case operator is we need square brackets, and then we add the string for case. And then we're going to add a true or false statement here. And then, so you can think of this like a case or an if-else statement. So we want to check, first of all, we want to check if the collapsed value of the parameter is equal to sales. So we can say, take this from before. We'll just copy this in here. So we know this is the single parameter value because we just saw that printed here. We basically want to check, is this equal to the string of sales? And if so, then we want to react to that. Now in JSON, the way that we do the equals sign is we have to use the equals operator, which looks like this. And basically the way that this operator works is it says, checks if the next two items are equal. So if object A is equal to object B. So in our case, if the collapsed value of the parameter is equal to the string of sales. And if it is equal to sales, then we can reference the data value at index 2, which is our sales. So 0, 1, 2. So if that parameter is equal to sales, we're going to use the sales value as the size of our slice. We can also repeat this for the other possible values of our metric parameter. So I'll just copy this down below. And so now we'll say if it's not equal to sales, if it instead is equal to profit margin, then instead of index 2, we'll use index 3. So 0, 1, 2, 3. We'll use the profit margin value. And then lastly, if this is equal to quantity, then we'll use the index at 4, which is this final column for quantity. And we can just clean up this formatting and then apply the code. And now you'll see as we're already on profit margin, so we can already see that the values updated. So we're seeing 11, 12, 13, 10. If we switch to quantity, we're going to see these values update. So 2,169, 4,000, so on and so forth, and then back to sales for our original numbers. Okay, the next thing that you might notice as we go to these other ones like quantity and profit margin is that our formatting isn't quite right anymore. So all of our original formatting was based on using the sales metric. So quantity and profit margin should not have the $ as a prefix, and profit margin in particular should be marked as a percentage. So to fix this, we can use the same logic as before to set our formatting based on case logic. So I'll come back into the chart code editor, and I can actually copy this entire case statement, and we'll paste it up here for the data format. And I'll just reformat this. And in this case, instead of referencing different data, so different data columns, we're just going to provide a different formatting string. So I'll copy paste each of these in here, and then we'll adjust them as we need. So when our parameter is set to sales, we want the Y slice as a number with a $ prefix. However, when it is profit margin, we do not want the $ prefix, and we want to add a suffix for the percentage symbol. Similarly, for quantity, we do not want the $ prefix, so we can simply remove that. And we can also copy and paste this same block down to the tooltip, which will be a very similar process. It's just going to be a slightly different string. So we don't want the point name in front. So we can just simply replace these. And then once again, for sales, we'll leave the $. For profit margin, we will remove the $, and add the percentage, and we'll remove the $, for quantity. Now when we apply code, we'll see it updated already for our profit margin. And now we're seeing these percentages. So we see 11% for communications, 12% for energy, so on and so forth. As we switch our metric to something like quantity, now we see just the number. So 2,169 for communications, 4,000 for energy. And then of course, when we go back to sales, we get the original formatting that still contains that $. So this is a really powerful capability that allows you to define parameters for really whatever you want, and then react to user selections within your chart code. So this can be used for choosing different metrics like we're doing here. You can do minor formatting changes, like you could change different colors or different formatting, or you can even select an entirely new chart type. So I'm actually going to move to my other tab here, where I've already built out a full example that extends this idea. So in this example, I can choose both between different chart types. So I can choose between a pie, a line, or a column chart, and then also choose between the metric that's used to construct that, the same one that we built together. So if I come in here and I select a line chart, we'll see instead of the pie, we now have a line chart of our sales. I can still come in and change the metric. So now I've got a line chart of our quantity. And I've also got the same thing for a column chart. So I've got my column chart by quantity, my column chart by profit margin, and I can come back to my sales as well. So this idea in particular of choosing the chart type is also possible with native QuickSight visuals, but it requires that you create 3 entirely different visuals that you use the free-form sheet layout to layer them on top of each other, and then that you use conditional rendering with rules to show or hide each visual based on parameter selection. Here with Highcharts, we can do this all in a single visual. It doesn't require the free-form layout, and we can build all of the logic directly into our chart code. So as I open the chart code editor, and as I collapse some sections here, you see that our chart code editor is actually just one big case operator. So I have a parameter for chart type, just like we had for metric. I've got a calculated field for the selected chart type, just exactly the same way that we did for the selected metric. And then in our high-level case operator, I'm doing the same thing that we saw before. So I'm taking the unique, so I'm collapsing the column at index 2, so 0, 1, 2, that's our selected chart type calculated field column. And I'm just checking what that value is equal to. So if that value is equal to pi, if we've selected the chart type of pi, then I'm going to pass in an entire chart definition for that pie chart. So if I look at the chart definition here for the pi, it's pretty much exactly what we just created together in our other example. So we've got our pi plot options, we've got our data series mapping of type pi, we've got our tooltip, and that's it. Now below in the column section, when our chart type is selected as column, I've got an entirely different chart definition. So I've still got a similar plot options, but instead of type pi, it is type column. And then I've even got a completely different set of high-level properties. Because for a bar chart or column chart in this case, we have different requirements. So we have to format the X and Y axis and the legend, which are all things that are not part of the pie chart visual. So these can be completely distinct definitions of charts that we've added into a single code editor within that case operator statement. And then finally, as I scroll down, you'll also see the same thing is happening here for the line chart. So we've got a definition with X and Y axis, series is type line, and that same data mapping. So this is just an extension of the idea that we just saw with the metric selection, but now for the chart type selection as well. Now, in addition to the extra parameter for chart type, there are a couple other advanced customizations that have been done to this visual in particular that you might have already noticed that we can take a look at next. So firstly, you might notice that our sales and quantity values have this comma here. So this is a comma separator for their values. Now this might seem like a really small detail, but if we go back to our earlier example that we built together that doesn't have the comma, we see the space here and we can see the difference that it makes. Now actually adding these comma separators is a really common question that comes up, and the resolution is a little bit trickier than you might first assume. So if we open back up the chart code editor of our original example, and if we look at the data label formatter, this comma here, so like in the sales, for example, where we are controlling the format of that data point with the 0.0f, that means it's a number with 0 decimal points. This comma is actually supposed to indicate that it should be a comma separated value. And if we actually remove that comma and reapply the code, you'll see that the space goes away. So what's actually happening here is it's trying to add that separator, but it's adding a space instead of a comma. It's unable to add the commas. And some of the other methods that if you've used Highcharts before, there's some other methods to add commas as a comma separator, but those are not supported today in the QuickSight version of Highcharts. So the solution to address this until support for commas is added directly is to first turn our number to a string, add the comma ourselves, and then display the string value in the visual. So coming back to the complete example, if you look at the field wells for this visual, you'll notice that in addition to our numeric values of sales, profit margin, and quantity, we also have a couple of additional columns here for sales with string and comma, and quantity as a string and comma. Now, if we look at the chart code editor, notice how up here in the pie chart, for example, where we're using the case operator to give a value of y, notice how in addition to these properties, we also have additional properties called sales string and quantity string. And sales string is referencing the column at index 3, so 0, 1, 2, 3. So that's a sales string column. And then quantity is referencing the next one, which is the quantity string and comma. And actually, when we create these properties for sales string and quantity string, we scroll up to the section on the data label formats. we'll see that unlike originally, like what we have in profit margin, where we're using the y property formatted as a number, we're actually just taking the properties that we defined here from the string columns for sales string and quantity string for our sales and quantity. Just note, in this case, we didn't make a third option for profit margin because we know that the numbers aren't big enough to ever need the commas, at least in our data set. Of course, if you had a different data set, you could add as many string properties as you wanted for whatever metrics you wanted. But the numeric fields are still necessary. We still need the numeric value of sales, quantity, and profit margin because we still need to actually construct the visual themselves using this y property, which requires a numeric result. So we still need to use these fields for the y, which is constructing the size of the slice, or in this case, the actual height of the column. But the string versions of these properties, we can use those however we want for displays. So like displayed in the labels and in the tooltips, or things like in the titles and descriptions, things like that. So we can quickly take a look at how these calculations are made. If I open up the data panel on the left, and we'll actually start with the sales string, as this is going to be used in our next calculation for the sales string and comma. So if I open up this calculated field, we can see how this was defined. Now, I think it's important to note that we can't simply use the toString function on our sales column, on the original sales column. And this is because we are aggregating the sales values from individual records, summing them together for each industry in our final version of this visual. If we took the strings of the sales column before it was aggregated, then we wouldn't be able to get the final summed results, as we can't actually then sum the strings. Thus, we are calling toString after we've aggregated the sales, and we're aggregating it by a sum where we're grouping by the industry, because this is the type of aggregation that we're doing in our final visual with this pie chart or column chart. We've also added this decimal to int function. This is just to get rid of all the digits beyond the decimal point, as they aren't necessary for our use case. But the core of this calculation is toString of our aggregated sales volume, or aggregated sales field. We then use this aggregated version, this aggregated string version, in the next calculated field, in the final one, called sales string plus comma. So basically, in this calculated field, we start by using the string length function to determine the number of digits in each sales value. If there are 3 digits or less, then we know we don't need a comma. So for example, if our value is 100, it's had 3 digits, we know we don't need a comma until we're up to like the thousands with 4 digits or more. So if there are more than 3, we know we need at least 1 comma. Now in our case, we know that our maximum sales value will never have more than 6 digits. So we didn't have to account for cases where we needed to add more than 1 comma. But if in your data sets you do have larger values, then you could follow a similar logic to what we're doing in this calculation, just extend it to adding 2, 3, etc. commas as needed. So in our case, knowing that we only need to add 1 comma, we can basically split our string in half for the digits before the comma and the digits after the comma, and then simply insert the comma in between them. We know that there will always be 3 digits after the comma. So we can calculate how many digits will come before the comma by subtracting 3 from the length of the string, which is the total number of digits. We then use the substring function to actually take both halves of the string separately and then recombine them with a comma in between using the concatenate function. So down here in the comments, I've included an example. So if we had a sales value of 50,345, we would first do the string length of this to see how many digits there are. This is a string, we'd get the string length of 5. So knowing that there are 3 digits after the comma, we can subtract 3 from the total length of 5 to get 2, which is the number of digits before the comma. We then use the substring function to take the 2 separate parts, so the first 2 digits in this case, so 50, and the last 3 digits of 3, 4, 5. And then as a string, we're adding these together with the comma in between to get the final resulting string of 50,345 with this comma. So if there are any questions about how this calculation was done, or if this is unclear, I'm happy to go over this calculation in more detail during the Q&A portion. But basically, with this calculation, we've successfully converted our sales value from a number to a string with the desired comma separator, which, as we just saw when we saved this, We then reference this within our Highcharts and pass this into our data labels and also our tooltip, which you can see as I'm hovering over here. So we're using that to get better number formatting. Okay, with that being said, the very last customization that I have made to this visual is for the colors that you're seeing in the column chart. So I'll just close this really quick. And you see these colors here. So we see that they're all different colors for each bar. Now, if we go into the chart code editor, and if I find where this was defined, so this is under column, where I've got this color property. If I actually just comment out this property and click apply, you'll see what the chart originally looked like with it had a single color for each bar. Now together, I just want to break down the logic of what is happening in this color statement. So I'll just go back down. Here's this color statement. Because this uses another couple of important functions for get color theme and index of. So the get color theme operation will return an array of the colors set in the QuickSight theme. So I've got a theme applied to this analysis that you can see here. It's called any software queue. And this theme designates the data colors. And it basically cycles through a range of blue colors, starting from the dark blue, which we're actually seeing here, all the way to the lighter blues that we saw when we had the full pie chart. However, the way that some charts apply this theme, like column charts, is that the individual bars will all use the first color instead of cycling through each individual color for each bar, like I had formatted here originally. And this is actually true for the native column and bar charts as well, if you've ever used those before. However, we can use the get operation to get different colors based on an index value from our color theme to color these bars as different colors. So just as we did before when mapping our data, we can get individual values from the array of theme colors using get. So we can use a simplified version to show how we can select a different color. So in this case, we can define color again, and we'll say get from the theme color, and we'll get a specific index. So we'll get the value at index 1. When we apply the code, you'll see that the color of these bars update. So, but even in this case, all the bars will still be the same color. We're just choosing a different color from the theme. What we really want to do is we want to choose a different color for each bar dynamically. One thing that is different for each bar is the industry value, which we're seeing here. So if we could turn the individual industry values into different indexes that we could pass into get from our color theme, then we could get a different color for each bar. So one way to do this is to use the index of operation. So the index of, this finds the index as like a number of a provided value in a given array. So in this case, we're saying search within get column 0, which again is our array of industry values. So within the array of industry values, take the current industry value and search for its index. And this is what's happening with this part of the formula. So get item 0, this is exactly the same logic that we used above, get item 0. We're passing in the industry as the name field for the name of the slice or the name of the column in this case. So the exact same logic we used above, we're just using it down here in the index of. So for example, it would say the first time through in our for each, it would say get the index of transportation from the array of industry values. So that would be at index 0. Then it would say get the index of retail, which would be index 1, so on and so forth as we went through the different industries. We then pass in that index, which is different for each industry, into our get operation of the color theme, so that we end up getting a different index for each industry. And that's why when we uncomment this, we're getting a different theme color for each bar. So taking a step back, as I know we are running out of time for today, everything we've done has gone into this single visual here. But we've covered some core concepts that can be applied to whatever data you have or whatever visuals you want to create. Most importantly, we saw how we can use parameters with calculated fields to bring more advanced interactivity to our Highcharts, using JSON logic with the case operator to have our charts react to the user selections that are stored in those parameter values. We also saw how we can use calculated fields and string formatting to enhance our displays. In our case, this was used for better number formatting with the comma separator, as this is a really common use case. But ultimately, this process of adding additional fields and data properties, so as we saw here back in the properties, being able to add these additional ones that are not required. So we needed to have the name and the why, but the additional ones like sales string and quantity string, whatever you wanted in your case, these additional fields and properties that we can then reference in labels, titles, tooltips, etc., is also a powerful way for adding additional data to enrich your visual, even if it doesn't affect the core structure of the chart. So like our sales string and our quantity string, they aren't controlling the size of these bars. They're just used for enriched formatting of our labels and our tooltips. And then finally, we looked at how we can manipulate colors using JSON logic for more dynamic chart coloring, like in our column chart. So with that, I'm going to switch back to our slides to wrap up with some resources and some Q&A. So I'll stop sharing, and then I'll reshare. And here on this slide, we do have just some quick resources that we can share as you're going through and learning Highcharts or continuing to use Highcharts and building advanced visualizations. So the first resource is our Demo Central page, which is full of Highcharts examples. It's got lots of samples with the example code. So if you are looking to get inspiration or to see how some of these more advanced visuals are being made, that sample code is found on that page. We've also got some Highcharts documentation. So the core library, which is full of all the different example visuals from the core library, which is what we've integrated with QuickSight. So you can see all the different types of charts that you can add within QuickSight, as well as the Highcharts API reference, which just is a documentation of the different properties that are possible for each chart type. So it's a really good way to reference as you're building out these charts, either if you're looking to control a specific configuration, we just want to read through all the possible configurations so you know what you are able to do with these visuals. And then, of course, we've also got the QuickSight community that Madison shared earlier. It's a great place to ask questions, hear what's new, get more resources. There's lots of great things on there, as well as our free trial to QuickSight. If you've not gotten started, you can get started today with our QuickSight free trial to start building either with any of our other features, like our Q features, or with our Highcharts, as we just went through here today.